Hi everyone. Today we're going to study relationship between zeros and coefficients of a cubic polynomial. If alpha, beta, gamma are the zeros of the cubic polynomial ax cubed plus bx squared plus cx plus d. Take note that a here is the coefficient of x cubed. B is the coefficient of x squared. C is the coefficient of x. Then alpha plus beta plus gamma equals the negative of the fraction b over a. Next, alpha times beta plus beta times gamma plus gamma times alpha equals c over a. Next, alpha times beta times gamma equals the negative of the fraction d over a. Example 1. Verify that 3, -1, -1/3 are the zeros of the cubic polynomial p of x equals 3x cubed minus 5x squared minus 11x minus 3. And then verify the relationship between the zeros and the coefficients. When we observe the polynomial, take note that a equals 3, b equals -5, c equals -11, d equals -3. Now, to verify that 3, -1, -1/3 are the zeros of the cubic polynomial, we need to check that p of 3 equals p of -1 equals p of -1/3, all equal to 0. Let's begin with p of 3. We substitute this 3 to all the x of our polynomial. So we have this 3 times 3 cubed minus 5 times 3 squared minus 11 times 3, then minus 3. This 3 cubed times 3 will be 81 minus 3 squared is 9 times 5 becomes 45 minus 11 times 3 is 33. Then we have this -3. When we simplify this, the answer is 0. So p of 3 is 0. Let's proceed to p of -1. Evaluating this, we have now this 3 times the cube of -1 minus 5 times the square of -1 minus 11 times -1, then minus 3. Simplifying further, the cube of -1 is -1 times 3 is -3. Then the square of -1 is +1 times the -5. We have this -5 here. Then -1 times -11, we have +11. Then we attach the -3 constant. When we simplify this, we will get 0. Thus, the p of -1 is 0. Now we go to p of -1/3. We have now this 3 times the cube of -1/3 minus 5 times the square of -1/3 minus 11 times the -1/3 minus 3. When we simplify the cube of -1/3, we will get -1 over 27 times the 3 here, we will get the negative of 1 over 9. Then the square of -1/3 is positive 1 over 9. Multiplied by -5, we will have this -5 over 9. Next, -1/3 times -11, we get positive 11 over 3, then the -3 follows. When we combine the first two fractions, we will get negative 6 over 9 and simplify to be negative 2 over 3. When we combine positive 11 over 3 minus 3, we will have this positive 2 over 3. The negative 2/3 plus positive 2/3, we will get 0. Thus, the p of negative 1/3 is 0. We are able to show that p of 3 is equal to p of negative 1 is equal to p of negative 1/3, all equal to 0. Now, let us verify the relationship between the zeros and the coefficients. We have here the three relationships. Let's begin with the first. Substituting the corresponding values, we have now this 3 plus negative 1 plus the negative 1/3. Is it equal to the negative of b over a? And that is negative 5 for b over a is positive 3. On the left side, we can show that the integers can be a fraction. The 3 becomes 9 over 3, the negative 1 becomes 3 over 3, and this we have this negative 1/3 again, equals, the right side is simplified into positive 5 over 3. Simplifying the left side, it is now equal to 5 over 3 equals the right side with the same value 5 over 3. Therefore, the first relationship is verified. Let's proceed with the second. Let us substitute the corresponding values. 3 times negative 1 plus negative 1 times negative of 1/3 plus negative 1/3 times 3. Is it equal to c over a? The c is negative 11 over the a, which is 3. This 3 times negative 1 is negative 3. Negative 1 times negative 1/3 is positive 1/3. Negative 1/3 times 3, negative 1, equals the negative 11 over 3. We can combine this negative 3 and negative 1. It becomes negative 4, and that is equivalent to the fraction negative 12 over 3. Then plus this 1/3 equals negative 11 over 3. Simplifying the left side, we will come to this negative 11 over 3. That is the same value on the right side. Then we are able to verify the second relationship. Let's go to the third relationship. Let us substitute the values. We have this 3 times negative 1 times negative 1/3. Is it equal to the negative of d over a? The values are negative of negative 3. That is the value of d over a, which is 3. On the left side, we can simplify this into positive 1. On the right side, we have the same value, which is positive 1. Then we're able to see that the third relationship is verified. Example 2. Verify that 4, negative 2, 1/2 are the zeros of the cubic polynomial p of x equals 2x cubed minus 5x squared minus 14x plus 8. And then verify the relationship between the zeros and the coefficients. Take note that in our polynomial, a is equal to 2, the coefficient of x cubed. B is equal to negative 5, the coefficient of x squared. C is the coefficient of x, that is negative 14. And D is the constant, positive 8. Now to verify that 4, negative 2, 1/2 are the zeros of the cubic polynomial, we need to check P of 4 is equal to P of negative 2 is equal to P of 1/2. All must be equal to 0. Now let's start with P of 4. Evaluating this, we have this 2 times 4 cubed minus 5 times 4 squared minus 14 times 4 plus 8. This 4 cubed is 64 times 2, becomes 128. Then 4 squared is 16 times negative 5. We have this negative 80 here. 14 times 4 is 56. We have this minus 56, then plus 8. When we simplify these numbers, the answer is 0. So P of 4 equals 0. What about P of negative 2? Evaluating now, we have this 2 times cube of negative 2 minus 5 times the square of negative 2 minus 14 times negative 2, then plus 8. The cube of negative 2 is negative 8 times 2 will be negative 16. The square of negative 2 is positive 4 times negative 5, we get this negative 20. Negative 14 times negative 2 is positive 28, then plus 8. When we simplify the numbers, we will get 0. So P of negative 2 is 0. Then we go to P of 1 half. When we evaluate, we will get 2 times the cube of 1 half minus 5 times the square of 1 half minus 14 times 1 half, then plus 8. We simplify 1 half cube, we get 1 over 8, then times 2, we will get 1/4. Then the square of 1 half is 1/4 times negative 5, we will get negative 5 over 4 minus the 14 times 1 half is 7. Then we copy plus 8. When we combine the fraction 1/4 minus 5 over 4, we will get negative 4 over 4. That is equivalent to negative 1. Then negative 7 is here, then plus 8, all becomes 0. So P of 1 half is 0. Thus, we are able to verify that the 4, negative 2, and 1 half are the zeros of the polynomial. Let us proceed to verify the relationship between the zeros and the coefficients. Let's begin with the first relationship. We substitute the corresponding values. We have now 4 plus negative 2 plus 1 half equals the negative b over a, and that is the negative of negative 5 over 2. We simplify, the left side becomes 4 and negative 2 here becomes positive 2 plus 1 half. Is it equal to positive 5 over 2? The sum 2 and 1 half will give 5 over 2. That is equal to the right side. Therefore, we're able to verify the first relationship. Let's go to the second relationship. Let us substitute the values. We have 4 times negative 2 plus negative 2 times 1 half plus 1 half times 4 equals c over a. The c is negative 14 over a, which is 2. 4 times negative 2 is negative 8. Then negative 2 times 1 half will give negative 1. 1 half times 4 is positive 2 equals, we simplify this fraction as negative 7. When we simplify the left side, it will give us negative 7 that is equal to the right side. Therefore, we're able to verify the second relationship. What about the third relationship? Let us substitute the values. 4 times negative 2 times 1 half. Is it equal to the negative of d over a? Negative, the d is 8. We write it here, and a is 2. When we multiply, the left side becomes negative 4, which is equal to the right side that is simplified into negative 4. We're able to verify the third relationship.